We have discussed about the pacer. So, uh, the pacer we have discussed already. The, the reason we use the pacer is when the signal is sinusoidal, then there are three variables. For example, this is one circuit here, and inductor latches in this way. Then if the Vs is sinusoidal, like 100 cosine pi multiplied theta plus 45 degree. Then we discuss about all component. We want to discuss. We need to analysis this circuit. That means we want to know this voltage and this voltage and this current. So to calculate over here, we will analyze this circuit as we have learned in the last semester, the circuit theory first. So using that, actually we can calculate the all variables. We calculate VL, VR, maybe current I. It will be very complicated, but we can do that. It will be complicated, but we can do that. Anyway, that value will be, for example, A cosine 2 pi 10 t plus phi L. That will be B cosine 2 pi t plus R. That will be cosine 2 pi 10 t. I'm sure all variable of this circuit can be expressed in this form. Why? Because when the source is a sinusoidal, then the other component, the current and voltage, will be sinusoidal. And especially if the source's frequency, I mean the angular velocity, this is omega here, then this omega, the govern the all variables. I mean the same omega here, same omega here, same omega here. So if the source has a fixed frequency, the omega, then all component of this circuit has the same omega variable, like that. Then if the source is sinusoidal, then there are three unknown variables. What is that? Maybe magnitude, cosine, omega t plus pi, the pace. I mean, unknown variables, unknown variables, unknown variables. So we need to calculate all variables over here. But if the source frequency fixes like some variable here, then all other variables has the same frequency. That means we don't need to care about that term. We don't need to care anymore because we already know why source frequency is fixed. All other variables has the same frequency. So to get these component variables, voltage or current, we can use only two variables. What is that? Magnitude and pace. So we need to think about only two variables. Then how to calculate only magnitude and the pace. So to do that, we have very good tools to simplify the electric circuit, which has a sinusoidal source. That is a pacer. Pacer is all variables such as the current or voltage can be expressed by only magnitude and phase. So to do that, the phase can be applied to the only AC circuit because all variables are sinusoidal. So why? Because frequency is common. So when you express some variables, that will be the voltage, that will be current. To whatever it is, the variable can be expressed on the magnitude and phase. Magnitude and phase, it can be expressed in the two-dimensional plane here. Then we expresses the magnitude and phase. What is that? There is a complex number. So a phasor, a definition over here is a complex number that is used to represent the amplitude and phase angle of our sinusoidal. So if some variables, for example, A cosine omega t plus theta, then it can be expressed using only the magnitude and phase in this manner. So to define the phasor, it's just like that. We have some rules. And sinusoidal should be represented cosine function. Cosine. And the phasor can be expressed in the polar coordinate system. So A is a magnitude and theta is a phase angle. That is a phase. So already we discussed over here in the last class in how to express the current and voltage in any way. So we already discussed about how to express the phasor. For example, this is example 10.1 here. Then I1 is 120 cosine 400t plus 60 degree. You need to know that we need to define these notation here. Why? Because this is a radian, this is a degree. So we need to figure out that is not phasor, this is not radian, this is a degree. So this can be same expression. Cosine 400t plus, how much is it? pi over 3. Then you don't need to express this degree here. Anyway, then we can transfer the depth values I1 with the pager. So we like the capital letter I1, and we need to make omega. Omega means we have to know the depth values is omega. There will be magnitude is 120, and phase angle is 60 degree. This is the same with 120. Oh, excuse me. It's the same, but in this case, we can express the phase angle is in radian. This is a degree. The same things anyway here. Then I2 is, for example, 100 sine 400t minus 75 degree. Then we have a promise. What is that? The sinusoidal can be expressed in a cosine form, not sine. So we need to change that value is not sine, cosine, but cosine. So I can use that. We have our rule. Sine theta in the same way, cosine theta minus 90 degree. So we can use that. 100 sine can be expressed cosine. Then theta is here, value is theta 400t minus 75 degree minus 9 degree. So it can be expressed 100 cosine 400t minus 165 degree here. So that can be expressed as a pager. The capital letter is omega is magnitude is 100. 100 phase angle is minus 165 minus 165 degree. So this is the expression of pager. Very like that here. So because pager is a form, the complex number form, so we can express that is in the complex plane here. So what is that? If expresses the I1 and I2, then I1 is the depth values here. This is I1. So the magnitude is 120 and the angle is 60 degree. So I think I1 can be expressed in this manner. Then there will be 60 degree and magnitude is 120. Then we call that is a I1 phase. And also same way we can make a I2. I2 magnitude is 100 and phase angle is minus 165. So magnitude of here will be like that. Then the magnitude is here is (100) and the angle is minus 165 degree. So this is I2. This is a very useful tool to express the voltage and current in the complex plane. We will discuss about here. We will discuss about this later. So to express the complex plane, the pager, you can use the same mathematical approach using the complex number. Actually, complex number is the mathematical expression So because the complex number has a very useful to calculation the procedure. We can express the complex number in the two-dimensional plane, the real axis and imaginary axis. And we can add in, you can add the complex number, we can multiply the complex number, we can divide the complex number, we can subtract the complex number, and we can use the conjugate. We can use any mathematical procedure, the with complex number, and we can use all of the procedure to analysis electric circuit. Why? All variables of voltage and current can be expressed as the complex number, so we can use the complex numbers, the mathematical approach to analysis the electric circuit. So it is very important to be familiar with how to handle the complex number. So actually, to express the complex plane in the complex number, we define that is like that here. This is a real axis, and this is an imaginary axis here. This is the real axis, and this is an imaginary axis. Then we make any complex number here, then define that is a V, and A, and phase angle is theta. That means the magnitude of here is A, and this phase angle is theta. Then also, this can be expressed in the other form. That value, the real component of this vector V is A, and that value is B. That means A is the same with the real number of complex number V, and the B is an imaginary number component of complex number V. So V can be expressed as a polar form here, magnitude and angle, or it can express it in the rectangular form. It will be A plus JB. The relation of this form, A will be V, actually not, it should not be, actually it is, A is A cosine theta, and B will be A sine theta. So that is the polar form to rectangular form, or in reverse, the rectangular form, polar form. Then what's that? The magnitude of A will be A squared plus B squared. And the theta will be arctangent A will be when the A is positive, and or 180 degree minus arctangent minus AB when A is negative. And this is important here. And we need to know about the simple things here. So when we want to express is 1, this is a real number. One will be expressed in the vector form or the polar form here. 1 and phase angle is 0 degree. Then what's that? J is an imaginary number here. That means here J is here. This is J. Then there is a magnitude over here is 1 and angle is 90 degree. So J can be expressed in the polar form here, 190 degree. The same way, the -1 is the same way, magnitude is 1 and the angle is plus 180, or magnitude is 1 and phase angle minus 180 degree. The same things. And minus J is 1 minus 90 degree. Why? This is minus J here. So this angle is 90 minus degree 9. And this is also same with 1 angle is plus 270 degree. The same things. So this is useful when you know about here. The reason we repeat these contents, this is because very important. Actually, this is not difficult. This is very familiar with you guys because this is covered in the engineering mathematics or the calculus. So we would be very familiar with these things, but it is important because this is a kind of mathematical tools to analysis the AC electric circuit. So I want to express some, I want to solve some example here. It's 1-10-32. It's a rectangular and the polar form of phasors. I mean, if V1, this is the large, capital character. That means the phasor. So 4.25 and 115 degree. And V2 was -4 plus J3. Then I want to change this V1 to the rectangular, the form of phasor. Then how to that? We need to change it. We need to know then V1 is the real term of V1 plus J, imaginary term of V1. Then what is the real term of V1? It will be the magnitude 4 to 5 and cosine 105 degree. And imaginary of V1 will be 4 to 5 and sine 105 degree. So that value is minus 1.796. And that is 3.852. Therefore, V1 will be minus 1.796 plus J 3.852. We can calculate this way here. Then I want to change the V2. V2 is magnitude and phasor values. Then what is A? Because this is a form of the rectangular form. So we can use square minus 4 square plus 3 square. That will be 5. And the theta, because the real term is minus, so there will be 180 degree minus arctangent minus 84 will be 3. And there will be 180 minus 37 degree. Approximately the 37 degree. There will be 143 degree. So can be expressed as magnitude 5 and phase angle is 143. So there will be 5 and 3 degree. Let's go. Let's go. So we need to know the Pager, the calculus. So we need to familiar with the Pager calculus. I mean, if we have the Pager, the V1 is complex number, A1 plus J B1, and that can be expressed as the polar form is E1 and theta 1. And we have another, the Pager, the V2, that can be expressed as A2 plus JB2 is a rectangular form, and that can be expressed as E2 and Z2. And then first, we can add here. How can do that? V1 plus V2. In this case, the rectangular form is more useful because the real can be added real with the real, and imaginary can be added in the imaginary. So there will be A1 plus J B1 plus A2 plus J B2. So real adding here and imaginary adding here. So there will be A1 plus A2 plus J B1 plus B2. In the same way, you can use the subtraction here. Actually, adding and subtracting is the same things. That will be A1 plus J B1 minus A2 minus J plus JB2 can be expressed A1 minus A2 plus J B1 minus B2. You can use here. These can be expressed in the complex plane. I mean, if we use these like that, for example, here real and that here. So we have this is for example, this is a V1 and this is a V2. And what is that? The V1 can be, this is A1, this is a B1, and this is A2, this is a B2. So adding the V1 and V2, we place the V1 plus V2 in here. That will be, this amount is A2, this amount is B2. The final value will be, here is A1 plus A2. That value will be P1 plus B2. So the adding can be explained in the complex vector diagram of a complex plane. This is very important here to understand the Pager and complex number. And second thing is multiplication or division. So for example, the V1 and V2 is multiplying, then polar form is more useful. In this case, this is E1 and theta 1 and E2 and theta 2. And so that is a magnitude and multiply each other. And Pager, when you multiply, two pays should be added here in this way. When you divide, V1 divide the V2, so that will be E1 theta 1 divided by E2 theta 2. Then magnitude is divided. E1 divided E2, and angle, phase angle will be subtracted here. So when you multiply or divide the vectors, I mean the complex numbers, the polar form is more useful. If you want to do this multiplication or division using the rectangular form, it can be, it's good, but it looks more complicated here. Then third is a conjugate. Conjugate, if the V1 is A1 plus JB1, so V1's conjugate is real term is the same, but the imaginary terms is the sign is reversed. If the plus is minus, and minus will be plus. So when you express that is term here, then there will be magnitude the same, but the phase angle is minus theta 1. What is that? In the viewpoint of the complex plane here, if this is a V1, the magnitude is E1 and theta is theta 1 here. The conjugate means this is B1, that will be minus B1. So this is a conjugate, A1's conjugate. So magnitude is the same, but the angle is minus theta 1. So conjugate can be expressed in this manner. So we can do this with simple example here. For example, V1 is minus 1.796 plus J3.852, and can be expressed in the polar form 4.25 and 105 degree. Then V2 is the same way here. In the previous, it's the same with the previous example. Is 5.143 degree. I want to now calculate V1 plus V2. What is better? The rectangular form is more useful to calculate here. So minus 1.796 plus J 0.852 plus minus 4 plus J3. Then minus 5.796 plus J 6.852. Then we want to multiply the V1 and V2. Then polar form is more useful. 4.25 105 degree multiplied 5 and 143 degree. So 4.25 multiply 5, and the phase angle is adding each other, plus 143 degree. So that will be 21, and angle is 258 degree. So they can be, another form is minus 102 degree. Then what is the division? The V1 divided by V2. In this case, the phase form, the polar form is more useful. So 4.25 105 and 5143 will be expressed as 0.85 and 105 minus 143. There will be 0.85 minus 28 degree. So you need to remember that when you say the page is the same, page identification. That means when you say the page is the same and V1 is V2 is the same, what condition can be satisfied V1 and V2 is the same? That is one here. If there are two pages in V1 and V2, then real of V1 and the real is V2 is the same, and imaginary V1 and imaginary V2 is the same. In this case, we can say the V1 and V2 is the same. Or another condition is in the polar form, the magnitude of V1 and magnitude of V2 is the same, and the page angle, V1's page angle and V2's page angle is the same. In this case, we can say the V1 and V2 are identical each other. This is a pager identification rule. Okay. So until now, we express the pager in the complex number. So there is we can express this pager with, pager representation is it's complex number. We have two forms. In polar form, what's that? V and page angle. Now rectangular form. What's that? That is, for example, A plus JB in this manner. Here I want to introduce another form of the pager representation. That is the Euler form. The same things, but a little different. To discuss over here, we want to remember the Euler's formula. Exponential j pi is the same with cosine pi plus j sine pi. So we can use it. So if we have some variable like a exponential j pi, a exponential j pi, that means they are the same with a and cosine pi plus j sine pi. So that is a cosine pi plus j sine pi. This is a very familiar form here. What's that? That is values. So these can be expressions of the magnitude and the pace, pi. Therefore, a exponential j pi is the same of a pi in the polar form. So we call, what's that? This is a pager, right? This is a complex number. So we call this the same with that. We call this as a exponential form of pager. So another name over here is exponential form. You express a, actually not a over here. In this case is v exponential j theta in this manner. This form is for the same things. So I will give you a simple example here to deal the voltage and current with the exponential form. So before that, we have some equation. If there are some equation here, expression a exponential j omega t plus theta, let it be here. I don't know what is that, but if the variable looks like here, then how can you express that using the Euler formula? That will be because of this, we can express that as a, what's that? Cosine omega t plus theta plus j sine omega t plus theta. And that can be expressed as a cosine omega t plus theta in this way here. Can you see? Here and here. Plus j a sine omega t plus theta. So what is that? This, what is this term? A cosine omega t plus theta means this is a, what is that? This is a real term of that. So there is a real component of a exponential j omega t plus theta here. That means because this is an exponential variable here, there is a real number of a exponential j omega t and exponential j theta here. So that will be real a exponential j theta and exponential j omega t. So if we have make a if you make some variable here, like let the v omega is a phasor, can be expressed as a theta, then that will be same with a exponential j theta. Then we can apply this form here. So where's that? So that will be real of v omega exponential j omega t plus that. You need to more explain again. Okay, can you a little bit complicated? So I will explain here. So from this relationship here, so we can calculate that this form can be expressed of the Euler formula. So I mean a cosine omega t plus theta can be represented of the Euler formula in this manner. So let there are some circuit here. Actually, there are some circuit. For example, there are some circuit here. And let the Vs, let the VST is a cosine omega t plus theta. Then phasor of V as omega can be expressed as A theta, and that will be same with A exponential j theta in this manner here. Then I want to express the VST from that values. Here I want to express the VST. This is time domain. This is a variable of time. This variable is the variable in time domain. But this variable, there are no time. This is in the omega frequency domain. So I want to express in the VST in the time domain using these pager domain here. Then how can do that? VST is cosine omega t. That will be same with that. This is A cosine omega t plus theta. That will be same with real component of A exponential j theta exponential j omega t here. So what is that? This term and this term is the same with here. This term is the same. So we can express deal of pager exponential j omega t is a time domain expression. So if you want to express some variable in time domain, you can use here. This is very important things. I mean, later we already learned about Laplace or Fourier. Then you very familiar with these kind of the expression. So this is a way to transport the time domain variable to the frequency domain variable, or the frequency from the frequency domain variables to the time domain variable. You can use it this form here. So anyway, you can solve that. The reason we discuss about here is I want to apply this pager, pager dimension is to the KC and KVL. And we already know that the reason we do this is we want to do this apply to the KC and KVL. I mean, we already know that all electric circuit has a this is quite, we need some more area. Okay. Okay. So the only law of the electric circuit is KCL and KVL. KVL is satisfied in time domain. But how about in frequency domain? Or how about in the pager? There's a question we have to do here. So you know that what is a KVL? I mean, we already know about here. Yes. In the time domain, KVL can be expressed this way here. I mean, what is KVL? There are some circuits, like the component here. I don't know what is that, but anyway, some component like that. And there are some voltages. This is a V1, actually. In this case, there will be V1, V2, I don't know, V3, V4. Then what is KVL? KVL means, actually this plus and minus, actually is V1 plus v2 plus v3 plus v4 will be 0. There is a KVL. So if we express this KVL in more general form, then all summation of all I, the v it is all I will be 0. There's a KVL. So I want to check this can be applied in the Phaser or not. So using this formula here, I mean the VT can be expressed in the Phaser form here. So I want to express this formula here. I will lead right here is I as the VIT is 0. And I want to express VIT. I mean here, what's that? VIT in the same way, if VIT is AI cosine omega t plus theta I, then we can express that is in the Phaser form. What is that? The number of the VI is the Phaser. VI is Phaser and exponential j omega t from here. So that can be expressed as VI. This VI can be represented this form here. So there will be sigma all I. VI is real number of VI Phaser and exponential j omega t here. So that will be same way. This is real, so the real, this is same with real of, because this is the sum here. I mean, so there is the same way all I and VI omega and exponential j omega t. And this is the same way real. The exponential is the common term here, the j omega t and sigma I VI omega. So I mean in KVL is always satisfied in the all time. I mean always this can be satisfied because should be satisfied in all t, always. So whatever it is, whatever t, that value, that this is should be satisfied. So to do that, that is a 0, right? Because this is a KVL. So in whatever the value of t, that should be always 0. Therefore, except of this term, the real of sum of VI omega should be 0 because you don't care about the time. So, for example, let t is 0, so this term can be expressed here is the real, because t is 0, it is 1. Sigma I VI omega should be 0. Or t is 2 omega t, 2 omega pi here. Then where's that? This is the real is exponential j omega 2 omega t is pi vi omega should be 0. Then what's that? This is omega omega. That will be real exponential j 2 pi vi omega. Then what's that? Exponential j 2 pi over 2. There is a 90 degree over here. So that is that. I mean exponential j. That is a cosine 2 pi plus j sine 2 pi. This is 0. This is 1. So that will be same with the j. So there will be j. So what is that? This is a real term. This is the real term of the j, and the vi is a plus jb in the rectangular form of the vi. So there will be real ja minus b. So that will be same with minus imaginary of this term, the sigma I is vi omega. So that should be the 0. Therefore we can get it. Sigma I, the vi omega, will be same with the real number of sigma I vi omega and plus imaginary sigma i's vi omega. That will be seen. But from here we got it. That is 0. This is okay. Actually, this is a j. And this form is 0. So this is a 0. So therefore, that is a 0. So what's that? As the KVL, the time domain, all variables, all voltage in the loop, the sum of loop voltage is 0. In the same way, in the pager, all pager sum is 0. Therefore, we can say pager we can use the KVL. So KCL can be expressed in the same way. So KVL, when you analysis electric circuit in the time domain, we use the KCL and KVL. So therefore, if we want to analysis in the pager, we need to check the pager satisfy the KCL and KVL. Through these procedures, we can prove that the pager can be used using, we can use the KV and KCL with the pager. So that's the reason we discuss of this procedure here. This is an example here. Example 10, 3, and 4. So we can use the KCL and KVL for AC circuits. Okay. So from the AC circuit, in summary, because if a set of sinusoidal voltage VI satisfy KVL for some AC circuit, the corresponding pager voltage VI satisfy the same KVL equations. Similarly, a set of the sinusoidal current satisfy KCL for an AC second, the corresponding to pager, the current, the pager I, satisfy the same KCL equations. So regarding to the pager voltages, the KVL is all the pager voltages, the sum of the all pager voltages is 0. The KCL with regard to the pager current, all the pager current the sum of all pager current is 0. So from these procedures and this sequence, we can prove the KVL satisfy in the pager. So this is an example of here. Okay, so this is a circuit here. Then the source is Vs expressed in this manner in 25, and the capacitor voltage is 20 and cosine 100t minus 22 degree. So omega is fixed. What's that? Omega was 100. The unit of that is radian per sec. It's a fixed. We want to determine the VR. There's a question. So we can use the KVL. How we can do that? We can use KVL. I will start here and define before that. This is Vs and this is VL and this is VC. I will start here. I will start here. I am at first minus Vs. So minus Vs. And I'm at plus VL and plus VL. And I'm at plus VC. Then plus VC. And I'm at a starting point here. Then there will be 0. This is a KVL here. Right? So KVL, based on the KVL, we can write the minus Vs plus VL plus VC is 0. Therefore, VL is the same with Vs minus VC. Then Vs is from the problem 25 cosine 100t plus 15 degree minus VC is 20 cosine 100t minus 22 degree. There's a VR that we calculate here. So how to calculate here? That'll be quite simple, but it looks very complicated. Anyway, you can do that here. I want to get the depth values. If you answer in this manner, I cannot check this is the right answer. We need to more calculate. So to do that, the VR is 25 cosine 100t plus 15 degree minus 20 cosine 100t minus 20 degree. Wow, it's quite complicated. So to do that, what should we do? We need to use these thing here, cosine plus minus alpha, cosine alpha plus minus beta will be, what is that? Cosine alpha, cosine beta minus plus sine alpha, sine beta. We can use this item. So at first, we need to re-expression of that. There will be 25 cosine 100t and cosine 15 minus sine 100t and sine 15. So You can recalculate, then cosine 15 sine 15. That result is 24.15 cosine 100t minus 6.47 sine 100t. To do that, you need the calculator. Wow. Then we need to do that here in this form. The 20 cosine 100t minus 20 degree. That will be 20 same way cosine 100t and cosine 20 degree and plus sine 100t and sine 20 degree. And that will be, we calculate cosine 22 and sine 22 into 20. So that will be 18.54 cosine 100t and plus 7.949 sine 100t. Then we sum over here. That will be VR will be expressed. Actually, no, not plus. Actually, this is minus. Okay, because we have to minus here. So that will be 24.15 and 18.54. Then that will be 4.61 cosine 100t and minus 6.47 minus 7.49. So that will be 13.96 sine 100t. So to simplify this term, we summarize that the magnitude over here is 5.61 plus square and 13.9 square and cosine 100t minus arctangent, because this is positive, so we can use it here. 5.61 and over minus this one and minus 13.96 this manner. So that will be 15 cosine 100t and plus 68.1 degree. Wow. So we can calculate the VR in this manner. It looks very tired, right? And there are many errors. That could be many errors. So another solution, this is the reason we use the pager. Another solution, this is the reason why we discuss about the pager. I want to solve this problem in the pager. Now from here, what is the VR? We can transfer the VR. VR omega will be Vs omega minus Vc omega. No. Then what is a Vs omega? Vs, and we can calculate Vs omega is from here. The Vs omega will be magnitude is 25 and angle is 15 degree. And what is the Vc omega? Vc omega magnitude is 20 and magnitude is minus 22 degree. So we can use here so that will be Vs is 25 15 minus 20 minus 22 degree. So it could be a little bit complicated. So we will use the VR omega will be, because this is kind of a subtraction, then what is better? The rectangular form is better. So we can use it 25 cosine 15 degree plus j 25 sine 15 degree. And minus 20 cosine minus 22 degree plus J20 sine minus 20 degree. So that will be 24.15 plus J6.47 minus 18.54 minus J7.949. Then we can calculate the real and imaginary each other. So that will be 5.61 plus J13.96. So we can calculate that the magnitude over here is 5.61 squared plus 13.96 squared, and the phase angle over here is, because it's positive, so we can make a variable is 68.1 degree. So there will be 15. So therefore, VL pager is 6.1 degree. So VLT is magnitude is 15. So 15 and cosine omega is 100t plus 68 and 1 degree. So this is the same result. The same result over here. So what is better? This looks better. But we have the same calculate. You know that you need to see here is 2415, and here 1854, the same value over here, and 6.47, and 7.49. There are similar variables here, but only different thing is, in the pager, ignore the frequency omega. So we can simplify the calculation. So there is very strong things that we can deal with the AC circuit with the pager. There is a reason we use the pager when analysis the AC circuit. This calculation is more simple, and more we can analysis in the voltage and current in the complex plane. Then we can have an insight about the circuit's characteristics. So I told you that the reason we discuss the electric circuit using pager in the AC circuit is, one thing is we need to simplify the calculation to analysis electric circuit. Second thing is we can get the insight about the circuit's characteristics from the complex plane, the phasor diagram.